morning everyone.
Morning.
First and foremost, all praise to the Almighty, the Benevolent for His blessing and guidance for giving us a chance to be here. As everyone knows, I, Mr. Shami, as the MC for the forum today. Without any delay, let's move on to the topic. Well, our topic for today is graphene as a bulletproof material. Everybody can use common. What do we mean by graphene? Why is it that everybody can use common? I hope every one of you have good explanation on that. Because I'm really going to work out many and different type of questions dealing with graphene. So, here we go to introduce our first panel, Ms. Sandra, Secretary at Legal Defense Industry, Professor Aiman, from Institute of Material Study as the second panel. The third panel, Mr. Habibullah, CEO from Diamond Tax, and our last panel, Ms. Sagita from the Oxford University under Chemical Faculty. So, let us proceed our discussion with Ms. Sandra to brief us on the definition of graphene.
Hello everyone, I'm Sandra. I would like to brief you about the introduction of graphene. Graphene is extracted from graphite, which is how it gets its name. In fact, graphene provides the structural basis of all other graphite materials, from graphite itself to minerals such as carbon nanotubes, buckyball, and etc. Graphene is one atomic layer of carbon atoms arranged in a hexagonal lattice. It is the building block of graphite, which is used among other things such as in pencil tips. On the other hand, graphene are remarkable substances on its own with a multitude of astonishing properties which repeatedly earn a title of wonder material. Besides, can you imagine that graphene is the world's first two-dimensional material and it's more than 1 million times thinner than a human hair, 200 times stronger than steel, and the most flexible material known to exist in this world? Obtaining pure graphene manifold is difficult, and until 2004 it was assumed by many to be impossible. According to Marshall A. Scientific American, a sample smaller than the weight of a human hair will be approximately $1,000, making it currently one of the most expensive materials on the face of the planet.
Sorry to interrupt, but can I just ask you a question?
Yes, you do, Mr. Shamil.
What about the wonder of graphene?
That was a good question, Mr. Shamil. When it comes to the founder of the theory of the graphene, was explored by Pierre Wallace in 1927. To be more detailed, in 1859, Benjamin Brodie was aware of the highly linear structure of thermoprevious graphite oxide. The structure of graphite was finally solved in 1916 by the related method of power diffraction. It was studied by detail in visculture and Behan in 1980. In a nutshell, 2 years later, 2004, Andrew Gill and Kostya Noskov at the University of Manchester extracted single atom tape sliced from gold. It remains to be seen what ultimate use will be obtained from graphene, but research in this area is extremely modern. Here are just of the few amazing properties that have been covered on the site. Graphene soaks up osmium July 2010, and here are the feature of Andrew Gill and Kostya Noskov.
Thanks, Ms. Sandra. Next, let us listen what Professor Aiman has to say on the characteristic of graphene.
With pleasure, I'm Professor Aiman will explain more on the characteristic of the graphene. Graphene is the stronger material. Okay, let's play a tricky game. What do you think if graphene and steel is being compared? Which one is the strongest?
Steve?
Steel is the strongest.
I'm the same with Sagi.
There you go. Sorry, every one of you are wrong. Graphene is the strongest material that ever exists, even it is the thinnest. thinner than a hair, as what we just said now. And one of the most useful properties of graphene is that it is a zero overlap semiconductor with both holes and electrons as charge carriers with a very high electrical conductivity. As you see in the picture, carbon atoms has a total of 6 electrons, 2 in the inner shell and 4 in the outer shell. The 4 outer shell electrons in an individual carbon are available for chemical bonding. But in graphene, each atom is connected to 3 other carbon atoms on the 2-dimensional plane, leaving 1 electron freely available in the 3rd dimension for the electronic conduction. These highly mobile electrons are called pi electrons and are located above and below the graphene sheet. These pi orbitals overlap and help to enhance the carbon-to-carbon bonds in graphene. Fundamentally, the electronic properties of graphene are dictated by the bonding and anti-bonding, the valence and the conduction bands of these pi orbitals.
May I interrupt for a second, Mr. Chairman?
Of course, you may, Saida.
As I knew that the 3D version of graphene has a laser thermal conductivity of over 1000 watts per meter graphene. But how about the room temperature and stability?
To answer the question, the new room temperature and the thermal conductivity of graphene was measured to be between 4.84 plus or minus 0.44. The ballistic thermal conductance of graphene is shown to be the lower unit of the ballistic thermal conductance per unit circumference and the length of carbon nanotubes. In addition, despite its 2D nature, graphene has 3 acoustic quantum modes. To be more detailed, some graphene quantum displays negative diameter parameters. At low temperatures, where most optical modes with positive diameter parameters are still not excited, quantum frequencies for such modes increase with the in-plane lattice parameters since the top in the layer quadrant. At low temperatures, when most optical modes with positive diameter parameters are still not excited, quantum frequency for such mode increase with the in-plane lattice parameters in the layer of constraint will be less mode to move in the z direction. This is similar to the behavior of the string. When it is being stretched, we have vibrations of smaller amplitude and higher frequency. This phenomenon was named membrane effect, was predicted by Lipschitz in 1952.
Wow, that's beautiful. Can you imagine that small heterogeneous has unbelievable power? Oh my god, I really can't wait to hear the function of graphene. So, let us have a picture of you from Mr. Minu.
Hi friend, nice to meet you. Well, if you see, there are many uses of graphene. But to be more specific, graphene are used in making strong and reliable battery for smartphones.
OMG, do you mean that my phone screen is made of graphene?
Yes, certainly, Mr. Shami. Besides, graphene also are used in manufacturing of the heart monitor, chip making, and used as pressure sensor. Moreover, the most interesting part is graphene as anti-corrosion material. The single layer of graphene provides the same corrosion protection as conventional organic coatings. They are more than 5 times thicker. Even till now, scientists are doing research on whether copper or nickel directly made from graphene as it provides protection against corrosion. Furthermore, graphene are used in the production of lithium-ion batteries that recharge faster. These batteries use graphene on the anode surface. Material scientists have constructed round formol-like graphene microparticles by spraying graphene oxide droplets into a hot solvent, whereby a process making to deep spraying. The technique could provide a simple, versatile to make electrode material for batteries and supercapacitors, possibly leading to devices with improved energy and power density. Just as the researcher said.
Okay, but how about the uses of graphene fiber?
In 2011, Lim Lee and Hong Wei-Su from Tsinghua University reported a novel yet simple approach to fabricate graphene fiber from chemical deposition from graphene film. The method was scalable and controllable, delivering tunable morphology and core structure by controlling the evaporation of solvent with suitable surface tension. Flexible or solid state supercapacitors based on this graphene fiber were demonstrated in 2013. Scientists want to use graphene in electrode because it has excellent conductivity, stability, and high surface area. However, standard graphene production method is thin film that aggregate or stack, reducing surface area and making the material difficult to process. To harness the material electrical and mechanical properties while retaining its high surface area, researchers have recently tried to create three-dimensional graphene structures. Several groups have made graphene foam and aerogel, but these are unsuitable for electrode because they are too bulky and irregular. They have a low density of the carbon material too, say Sang Hong Park, a material scientist at Yonsei University in Seoul, South Korea. A few other groups have made less bulky graphene nanosphere and microsphere using 3D templates and techniques such as chemical vapor deposition and freeze drying.
That was a good information on the function of graphene. So, let's proceed with our discussion with Ms. Sagi on the advantages of graphene.
Good morning, friends. I guess all of you have an overall idea of graphene, so it won't be clumsy if I enlighten you with the advantages of graphene. Well, if you see, because of graphene, there are two major developments in nanotechnologies, whereby development in nanoplasmonic and development in nanoplasmonic. Nanoplasmonic is a relatively new field involving metallic nanostructures that can be used to fabricate miniatures, optical electronic devices. Metallic nanostructures interact strongly with light via localized surface plasmons. Not only that, if you see, they also act as efficient optoelectronic devices which can focus light through wavelengths but significantly below the diffraction limits. So, I'm just passing around this to have a look. Since many metals are magnetic, nanoplasmonics often spills over into nanomagnetisms. Because of that, researchers and utility effects have already been observed. For example, diamagnetic particles can also develop magneto-optical properties and a special type of magneto-optical Kerr effects that erases from propagating all localized surface plasmons that also been observed in structures such as cobalt, gold nanosandwiches, gold-coated metallic nanoparticles. In contrast to such studies of hyperplasmonic and ferromagnetic materials, the researchers at Commerce and Nanopin have now investigated localized surface plasmons flaws.
It sounds quite interesting. So, Ms. Sagi, is there any explanation on the advantages?
Oh yes, essentially. The vortex navigate transmission, a significant part of energy, is converted into an inherently loosey kinetic motion of free electrons and it is dissipated rapidly as heat. Furthermore, the technology is aimed to achieve significant performance improvement to nano devices fabricated with standard plasmonic materials such as silver, gold, and aluminum. The achievement allows the reduction of dissipated losses and increase the amount of energy that accumulated.
Throughout our discussion, it is proven that graphene as a bulletproof material everybody can use as well as we. We even can conclude that small little can bring benefit to the humankind. As the older people say, don't ever judge a book by its cover. today. Thank you for playing an active role. And lastly, not to be forgotten, let's give an applause to all our brilliant and knowledgeable friends. Thank you, bye, and take care. Good job, guys.